the log, my viewing log.
Hello, cloudy sky refugees, and welcome to the January online viewing session hosted by the Kalamazoo Astronomical Society. My name is Richard Bell. I will be your host for this evening. I am the current president of the Kalamazoo Astronomical Society, and I want to welcome you all here tonight. So we got a great program shared. Oops. I got to mute my TV. So we're on a 20-second delay there on YouTube. And so I want to apologize for kind of pulling a switcheroo on all of you last weekend. At first, we said we were going to go for the session, but then the wind was a bit worse than I had hoped. Not really bad, but there would have definitely been 15 minutes there where we would have had a little interruption if I didn't change at least the safety settings that we have, which I have done tonight, but I don't think we'll have any trouble. The wind's much calmer than predicted. So let's just go ahead and jump right into it. So let me share my screen here and we'll get started. So again, welcome to the online viewing session for January 16th, 2021. Here's a lovely scene of Peishi Observatory, a nice sunset by Mike Patton. So this is an older photo of Peishi Observatory, but it's still relatively accurate. So this is the home of the KAS Remote Telescope. This is a 20 by 20 roll-off roof observatory. And in this case, the roof is rolled off and you can just see the remote telescope there peeking out a bit. Of course, this is its park position because we would have an issue with the roof there, but we pop it up there for, photographic purposes. And one thing no longer are not seen in this shot is what's supposed to be a all-sky camera right back here, because this is a photo previous to that installation. So this is what the all-sky camera looks like today. So it's a pretty simple all-sky camera, and it is a color camera, and this allows us to view constellations and, more importantly, to check the weather. So let's go ahead and take a look at the all-sky camera. Switch over there. Give it just a second. And there we go. So this is the current all-sky camera. If you read the text down here, which of course no one ever does, it's updated every 4 minutes. The one thing I don't mention here is this is a roughly 1 minute exposure. And of course, the first thing that catches your fancy is this really bright, obnoxious object right there. And of course, that is the moon. So currently we are in a waxing crescent phase, but you wouldn't know it from this image. But just remember, this is a 1 minute shot, so it is very much overexposed. And you can imagine what the full moon looks like on the all-sky camera here. So I have you can see the address here. All you have to do is go to the remote telescope tab and scroll down to the Peishi all-sky camera, and that'll take you to this page that we have right now. I'll come back to this page from time to time, just sort of check in, see what the sky looks like. Maybe we'll see a cool meteor. But if you do see something interesting, do give me a holler, either perhaps in the chat, and eventually here I will unmute you. But we're going to be a little extra precautious with security, considering the minor issues that we had last time. So let's take a little tour of the sky. Now, north is directly up, south is at the bottom, west is over on the right, and of course, east would be over on the left. And one thing that the moon kind of washes out here, you can kind of see it, but you might just mistake it for afterglow of the moon, is the zodiacal light. So the zodiacal light is basically dust ejected off of comets and asteroids that settles into the plane of the solar system. And sunlight reflects off all that dust. And so if you can see the zodiacal light, that is a sign of very dark skies. I've never seen the zodiacal light from Michigan, Perhaps it's visible from upstate or especially the UP, but I've only seen it out west. And the fact that you can see it just a little bit through the moonshine there, that's pretty impressive. We can follow the Milky Way kind of arc through the picture here. Over here, and you can see it just updated because it does update every 4 minutes. You can just catch a little bit of summer. This is the star Deneb, part of the summer triangle. So, yep, summer is long gone. No more summer triangle, but it'll be back in a few months. And we can meander up the Milky Way here and see the familiar W-shaped constellation of Cassiopeia. Kind of below Cassiopeia and above the moon is the Great Square of Pegasus. So the Great Square of Pegasus is a very famous asterism, sort of the dominant asterism of the autumn, of fall. And these three stars here belong to Pegasus. You can make out the head of the horse down there because the horse is flying upside down. And there's kind of a leg going off here, a leg going off there. But this star called Alpheratz, that belongs to Andromeda. In fact, it is her head. And you can basically follow, it's a little tough here, two arcs of stars that kind of form the constellation of Andromeda. It's basically 3 stars in a row and kind of a curve that meet at Alpheratz there. And just above over here somewhere is the Andromeda Galaxy, which we did look at last month. So if you missed it, oh darn, you'll have to wait till next year. Below Andromeda here, sort of at the highest in the sky, is the planet Mars. So we can still see Mars, Jupiter, and Saturn, and their great conjunction is long gone, so they have long since set. But over here in the western sky, or the eastern sky, we have the winter sky, including the winter hexagon. We can start from Betelgeuse, go up to Aldebaran, Capella, Castor Pollux. Pollux is technically the corner because it's the brighter of the two. Procyon, and the brightest star in the night sky, Sirius. So there we have the winter hexagon, the dominant asterism of the winter. Of course, Rigel is part of Orion's left leg. You can see Safe here. There's 3 stars in a row, his famous sword, his right armpit or shoulder, and his left shoulder. Of course, Betelgeuse here, this wonderful kind of red-orange supergiant, that literally means armpit of the Great One. So it's like he has a giant orange boil in his armpit. I know it's kind of a terrible figure in your head. And just above his shoulders is this tiny little head. He's all brawn. He's not much in the way of brains. So he does have a pretty tiny head there. You can just kind of make out a curve of stars here for his shield as well. And his club kind of goes up toward these 2 stars here. So he's holding up that club and the shield because he's being charged down by Taurus the bull here. So we have the bright star Aldebaran along with the Hyades cluster. Aldebaran is not a member of the Hyades, but Aldebaran and the Hyades together, they make up the face of Taurus the bull, while the horns kind of go off this way and this way here. On the back of the bull is a Pleiades. We'll see that up close here fairly shortly. And with Capella, we have this kind of house-shaped constellation that is Auriga the Charioteer. Gemini, with Castor and Pollux, it kind of generically looks like a box, but there's kind of a stick figure here. There's 2 little short stubby legs here with an arm there, kind of an arm here and a little stick body. His brother has like a little head neck with 2 little short arms. They're kind of holding hands here with a body and 2 long legs. There's a kind of a long curved leg there, along with a bull leg there. Procyon is part of Canis Minor, the lesser dog. It is the easiest constellation to draw because it's just Procyon and Gomisa there. And that's it. Those 2 stars right there. And with Sirius, that is famously known as the dog star, but we can't see most of the dog right now. His head is right here. There's like 1 paw here, and his body is in the process of rising. So we'll perhaps take a look at Canis Major a little bit later. And if we're here, we should be here for a couple hours, so we might see some spring stars pop up as well. All right, so as always, we're going to start with our wonderful Takahashi telescope that rides piggyback on the main telescope. So I don't want to give you too many details of the Takahashi. If you are interested in more information, of course, you can read the little table here. But on our website, in our remote telescope section, there's an entire page called instrumentation, and you can read all about the instruments there. Basically, this is a 4-inch refractor with a 530 millimeter focal length. So with our camera, it gives us a fairly good field of view, basically 4 degrees square. So it takes up a fairly decent chunk of the sky. You know, 4 degrees is 8 full moon widths. So that covers quite a bit of territory. And this is the cameras that we use. We have one on the Takahashi, and we also have an identical camera on the Planewave. So we have an SBIG STX 16803 CCD camera. It is a full format camera that does give monochrome images. People often ask to see these objects in color during the sessions, but to do that, we have to take images through red, green, and blue filters, and that takes time and processing and stuff like that. So all the images that we'll see are basically in grayscale. And you might ask, well, why? Why not go color? We have color cameras, but for the serious imaging that we do with the Takahashi and the Planewave, monochrome cameras give much finer resolution than your standard point and shoot color cameras, either the cooled CMOS cameras or even the DSLR camera that you use for, you know, vacation pictures. So here's our very first target of the night. We'll start off with a bang. So we're going to begin with M45, the famed Pleiades cluster. So let me switch back to the browser. Here we go. And I'm going to switch to my other tab. And here we have the web interface for the astronomer's control panel, what we call ACP. So ACP is basically a kind of Swiss Army knife type program. It's a program that controls programs. So ACP controls the programs that control the camera, the mount, the focusing, and the autoguider, and so on. So we can access this through this web interface, so no one has to install any software on their computer, and basically anyone with a computer and high-speed internet connection can access the remote telescope, if of course you're a member that lives in our area. So I have this all set up and ready to go. I've already typed in M45. I'm just going to hit that one more time because I've been very guilty of forgetting to hit the get coordinates. You can see I've done it a few times there. And so we have the right ascension declination. It's all taken from the computer. We're going to use a clear luminous filter, and we're going to take a 5-minute shot. So I'm going to hit that, and off it goes. And what will happen here is it'll do some plate solving. It'll basically use a previous survey of the sky to match a test image it takes to perfectly center the Pleiades, and then it'll look for a guide star. Although with the Takahashi, we could probably take a 5-minute shot and not get too much trailing. It's pretty wide field of view. So I'm sure you're all familiar with the Pleiades, also known as the famed Seven Sisters. It's obviously very bright. I'm sure many people at one time or another have seen the Pleiades for themselves. Many people mistake it for the Little Dipper, because it does look very much like a little tiny dipper in the sky, but this is not the Little Dipper, but you can really call it the Mini Dipper if you want. With asterisms, you know, there are no rules. It's pretty decent size, and as far as open clusters go, it's very close, only 444 light years away. So as you know, it's referred to as the Seven Sisters after the 7 doves that carried ambrosia to the infant Zeus, or the 7 sisters who were placed in the heavens so they might forget their grief over the fate of their father Atlas, condemned to support the sky on his shoulders. Now, it's of course called the Seven Sisters, but there are 10 stars brighter than 6 magnitude. So if you're at a dark site and you get really dark adapted, spend some time with the Pleiades and see how many you can find. Just spend some time at it. So it's pretty easy to find the Pleiades. It's right between the Hyades and Taurus and sort of the bottom of Perseus. You can also kind of make a triangle sort of with Capella there. So I'm sure everyone can find the Pleiades. If you can hear some little beeping noises, that's my program looking for guide stars. And again, there are roughly 7 sisters, or 7 stars visible. Most people can see 6, but there are 7. So this view is from Sky Telescope's Pocket Sky Atlas. And this gives you a little closer idea where the Pleiades is, but this is a terrible example because it is, in fact, so easy to find. So here are many of the named stars of the Pleiades. We looked at the Merope Nebula last month, and you can see Alcyone. This is the brightest star in the cluster, along with Electra and several others. But if you do have exceptional eyesight, you can see up to 17 Pleiades from a very dark site. So, of course, that was done by the famed observer Stephen James O'Mara, who from Cambridge, Massachusetts, did count 17 stars in the Pleiades with just his eyes alone. So all you have to do is just spend some time on it. That's one of his main secrets, is you can breathe, oxygenate your blood, just get as dark adapted as you can, look at it intently, and you'll be amazed how well you can do. So obviously, because it's so prominently visible, it's been known since ancient times in cultures across the world, including China, Japan, Persia, Maya, amongst the Cherokee, the Aztec, the Sioux, and the Aborigines. And so the Japanese mention it as Mitsuurabushi, which means 6 stars, because most people on average can see 6 stars, as I mentioned. And this dates back to documents from the 8th century. And you may also know it's known as Subaru, meaning coming together or cluster. So if you take a look at the Subaru logo for the cars, you can tell they got a little star cluster pictured on there. It doesn't really look like the Pleiades, but you get the idea. So Pleiades, Subaru, take your pick. And the Pleiades was also mentioned in the Iliad, Homer's Odyssey, the Bible, and the Quran, amongst many other texts. So it's been fairly widely observed. All right, let's hop back to the program here and ACP and see how we're doing. All right, so it looks like we found a guide star. The guiding looks fairly smooth, and we're roughly halfway through our exposure. So let me stop sharing here for a minute, and I'm going to see if I can unmute everybody. I'm going to lose the chat. I thought it'd be easy to unmute everybody. Oop, it helps if I hit the right button. Okay, so you should be able to, I think you can unmute yourself now. The little controls for unmuting everyone is not here. So we have roughly 2.5 minutes to go. So anybody had any quick questions, I'm happy to answer them. You can try to ask in the chat, but I'm historically bad at following the chat, or just go ahead and try to unmute yourself and ask a question. We don't want to be unmuted. Well, maybe, that's interesting.
Richard?
Yeah, Jackie, go ahead. There's somebody.
I have a question. Yes, you were not allowing us to unmute, but now
For a while there, yes.
Yes, I just have a question. That the Atlas star that we saw, is that not part of the Seven Sisters?
Yes, it is.
Oh, it is. Okay.
Yes.
I didn't see the little green cloud around it, so I thought maybe it was not part of it.
Nope. Nope. Atlas is. Atlas is one of the Seven Sisters. Okay, we're almost done there.
Thank you.
And I also had a question last week when we were going to have this presentation. It was right during the triple conjunction. Did we get anything from that?
That would have been a unaided eye or naked eye phenomena. We certainly couldn't have done that with the remote scope. We did have a bonus kind of online viewing session for basically members only, where we did look at the Great Conjunction on December 21st with the remote telescope. If you go back in our Twitter history, you can find those images that I took on December 21st.
I'm not on Twitter.
You don't have to have an account. You can still view our tweets. You can go to the link on our website and scroll back from there.
That's a good baby.
Thank you.
Good
Yep.
kitty.
All right, let's see how we're doing. We should be almost done. So let me go back to our screen. I like to keep everyone unmuted for the ooh and ah part. So feel free to ooh and ah. There we go. The Pleiades.
Ooh, wow.
Oh, thank you. I really enjoyed that.
Cool.
Very nice.
Oh, we're on the scope is on the west side of the meridian. The line that divides the eastern and western sky. It runs from due south through the Venus to due north. So that's why the Pleiades sort of looks upside down. Once the scope flips to the opposite part of the sky, that'll change.
That's a good baby.
Some people don't see anything, Richard.
You're not. Is everyone? Some people don't see anything at all.
Yes.
Well, let me. I'll stop sharing. Can everyone see me?
Yes.
Yes.
Okay. And let me try to share again.
That's a good baby.
And there we go.
That's a good girl. Good
I see
kitty.
that.
Good kitty. Wow, you're purring so loud.
So it's great we have a good kitty amongst the crowd here. So let me just tell you a little bit about the Pleiades. So the Pleiades is 100 million years old and composed of hot, blue, highly luminous stars belonging to spectral type B. If you're not familiar with the spectral sequence of stars, there's O, B, A, F, G, K, M. You can remember that by saying, "Oh, be a fine girl or guy, kiss me." So, "Oh, be a fine girl, kiss me," and you can remember the spectral classification of stars. So, type B is the second hottest of stars. The O types are the hottest, and the B's are the second hottest. Of course, each scale, O, B, A, F, they have 9 different levels of gradation. So these are all, many of these are generically type B. The Pleiades contains about 100 stars in a sphere about 15 light years in diameter and a tidal radius of 43 light years. It does have a total population of over 1,000 stars.
Wow.
Not including unresolved spectroscopic binaries. You can't forget those. They count.
That's my baby.
So remember, for those of you saying nice things to your kitty, everybody can hear you, so you might want to mute once in a while. Just a little warning there. Although it's great you're giving your kitty some love. So this cluster will survive for about another 250 million years. What happens is as open clusters orbit the galaxy, they encounter alien stars, and their members are gradually stripped away over time. So typically, clusters don't survive for more than maybe 1 billion years or so. And you can see there is a cloud really sort of clouds around the Pleiades that form what we call a reflection nebula. So reflection nebulae are blue, so imagine a nice blue cloud around the Pleiades. Of course, you can see that in many color images. So this nebula was once thought to be stars left over from the cluster's formation, but we now know the Pleiades is just passing through the Taurus Auriga complex of dark nebulae. And in fact, the Pleiades is kind of moving this way. If you look for like very deep exposures of the Pleiades online, you know, really long exposures, you can see the Pleiades plowing through the dust cloud. But we can only see the cloud nearest the stars that reflects sunlight. And of course, you can't see them in this image, but the Pleiades does contain many brown dwarfs, which are failed stars, stars that never ignited the hydrogen and the helium. And they actually make up about 25% of the cluster's population, but less than about 2% of the total mass. So there we go. We have the Pleiades, the seven sisters. And don't forget, as we speak, this image is being uploaded to our cloud account. After the session, I will download all of these images, do a little bit of processing because this image is processed a little, and you'll be able to download these later. I'll give you the link at the very end. All right, so I'm going to go ahead and just mute everybody again, and we're going to go on to our next target. So I hope you enjoyed the Pleiades. So our next target is IC, or Index Catalog 1805, the Heart Nebula. So I'm going to have to tell the telescope where to go. So give me just a second here. I'm going to let you look at this slide. And I'm going to type it in here. So just a minute. There we go. All right, we are off. All right, back to our screen here. It's always a little awkward using Zoom sometimes. There we go. That's the one I'm after. So this is a fairly faint object. I'm not sure, I have to double check that, but it is fairly faint. One of the great things about online viewing sessions like these is we can look at stuff that's typically very difficult to view through a telescope. So I'm not sure the magnitude is accurate. That could be fairly good. But this is technically a very hard object to view. And it is very distant, about 7,500 light years away. So of course, the name, the Heart Nebula, describes how the object looks in wide field images only, not visually. And it is also known as the Running Dog Nebula because that's how it can look when seen through very large telescopes. And it was discovered by William Herschel, a very famous observer, on November 13th, 1787. This is where you can find it in the sky. I made it visible here with the program Starry Night. Of course, you can't see these visually, and it's really hard to do through a telescope. But photographically speaking, they're pretty easy to find, although everyone uses a computerized telescope today. But it's just off sort of the more oblique angle here of Cassiopeia. And of course, don't try looking for Camelopardalis here, the giraffe. That's a pretty hard constellation to find. So here's a bit closer view of where we can find it. It's basically located about 5 degrees east-southeast of Epsilon, right there, Cassiopeia, or about 4.6 degrees north-northeast of the famous double cluster. which we did take a close look at last season, but maybe we could do that as a bonus object later, since I had not planned on doing it this season. So not too much to mention about this one, and sort of some colorful information there, but let's hop back to the program and see how we're doing. So what I have planned here is we're going to do a 10-minute exposure of the Heart Nebula with what we call a hydrogen alpha filter. Since this is a emission nebula, it gives off mostly hydrogen alpha light at a wavelength about 6,500 nanometers. So with the hydrogen alpha filter and a 10-minute exposure, it should look pretty impressive. And so it looks like it found a guide star, because it's blinking away there, and you can just begin to see the guiding airs there. And we just started our 10-minute exposure. So we have a bit of free time here. So let's use that. We'll kind of hop back to the all sky camera. Everything looks good there. You can see we can see the back leg of Canis Major now. And one thing I haven't showed you yet is the telescope. There it is. So this is our Peishi cam, which is a live view of the remote telescope. And it looks like it's fairly accurate because it's definitely pointed toward the high in the northern sky, which is where we find the Heart Nebula currently. And this is the telescope that we're using. Again, this is the Takahashi. This is our larger scope, the plane wave. And this is the mount, but I'll talk about that later. This little funny box here with kind of the white circle, that's our flat field box. It's a homemade one made by one of the sort of infrequent residents of Arizona Sky Village that gave that to us, but it didn't quite work as well as we had hoped. So we do have a new one on order. So eventually here you'll just see a big white screen there. And so this is the inside of Peishi Observatory. And of course, you can go to the remote telescope tab and go to the Peishi Observatory webcam. And that's the current page that we're viewing. So you can check out the telescope day or night. Of course, during the day, it's in the park position and the roof is closed. So you can just kind of see it sit there. And again, there's the link to the all sky camera. All right. So if I can remember, I'll kind of switch back to it and we can watch it move to its next target. So we probably do have quite a while. Before we're done there. So this is another great chance to say hi and ask a few questions. And if you are waiting, one thing I would like everyone to do, especially our guests, I know who all the members are. I know where you're from. I even have your address. I could come visit you. But if you are a guest in the chat, just sort of tell us where you're from. You know, what part of the US or possibly Canada or even overseas. And let us know if you're also part of another astronomy club. So we'd love to hear from you. And again, I am happy to answer any questions you have. Could be about the remote telescope. Could be about the Kalamazoo Astronomical Society. Could be general astronomy questions. You could ask about my little, oh, there he is. My little companion there. There he is. See him? In the lower right there. There he is. All right. So let's, hearing none, we'll hop back to ACP here. And we can show you perhaps a few other features there. So we're guiding away. Boy, look at that, is so smooth. And I could give you a behind the scenes picture here in a second, but I can show you a little more of ACP. So what we have here, each of these little boxes is called an item. I don't know why the developer just doesn't call it a window. But so here we have the single image item. So this is what I usually use for the remote sessions, or the online sessions as we call them now. And but of course you can do more complex images with the color series here. So with the color series, of course, you can take a whole series through various filters. And we do have 7 filters in all. We have the clear luminance filter, red, green, blue, to create color images. Of course, right now we're using the hydrogen alpha filter. We also have an O3 filter and a sulfur 2 filter. So our filter wheel holds 7 filters, and we have every single slot filled. And we do have the finest narrowband filters. That's what we call H alpha, O3, and S2. They're narrowband filters. And each of these has a 3 nanometer slit, which gives very, very fine detail. So they are about the best you can get. And you can see some other things here. This is where you can enter in a multi-object plan, but you have to create a plan offline. You can either write your own script or use a program called ACP Planner. Of course, to create really beautiful deep sky images, you have to calibrate the image. You have to subtract dark frames and flat fields. So we can take dark and bias frames. We can do flat fields all through the web interface of ACP here. The system status display is what's open now. The pictorial field of view is based on a star atlas that shows us the current view of the telescope, but it's roughly like this. Of course, we're looking at a different part of the sky now. Of course, we can look up information, instruments, and equipment. So right now you can see we have the Takahashi loaded in here. It's only 530 millimeters in focal length with about a 4-inch aperture. And again, it lists all the filters that we have. And of course, we can always check the weather. If we don't want to go to the website, we can click on here and check out the all sky or the clear sky chart. So it looks like the scene is predicted to be bleh kind of tonight. But boy, really late. By the time the sun pops up, the scene's supposed to get really good. Just what lousy luck is that? But we'll look at tomorrow night. So tomorrow night, the scene looks pretty good along with the transparency, but darn it, I don't have the scope reserved tomorrow night. Somebody else does. Oh, poo. This is totally not fair. We can check the local weather. Oops, where'd it go? Oh, there we go. Oh, so this is the local. This is what I thought it was going to be, but we can see the weather is safe. The wind is pretty low tonight, only about 2 knots, roughly what, 3-4 miles per hour. It gives the ambient temperature in Celsius. I don't know if there's a way to switch it to our standard, our goofy scale that we use here in the US. And of course, here's what I was thinking. Here we have the radar animation. Oh, it's not working right now. Huh. Well, that's interesting. Let's try it again. Oh, it's broke. Oh, you know what? The National Weather Service retired the one that we used before. Ooh, so we'll have to update that. I didn't realize that. They retired the classic all sky, or the continental US radar mosaic. So that means this has been retired too. So we will have to update that. Obviously, you can tell I don't use that very often. We can look up the dawn dusk time. So it didn't get fully dark until almost exactly 7 o'clock local time, because Arizona is on Mountain Standard Time. They never use daylight time. So you can also call it Arizona time. We don't really have anything on contact info, and there are a few other things. The utility tasks is already open, and so there's various things we can do. We can switch telescopes, start up telescopes, oops, and we have focus control and stuff like that. How are we doing there? Oh, pretty good time filling there, I think. We're almost done. Getting there.
Is the 5-minute exposure mostly due to the CCD camera, or would CMOS do better?
No, it wouldn't do any better. And we're doing a 10-minute exposure because it looks really good in H alpha. So no, CMOS wouldn't do any better. Especially considering what we paid for these cameras. But yeah, CCDs are becoming a little ancient, but this is still a very, very good camera. All right, it is done. I don't know why it goes 4 seconds past. For a while, it did that, then it stopped doing it, and now it's doing it again. All right, so don't forget to go ahead, see if you can unmute yourself for the ooh and ah part. That's my favorite part. There we go. Okay, now we have to wait for it to load. This is just a thumbnail. There we go, there's one. Okay, we'll click on that, and there we go. So we have the Heart Nebula, and obviously you can see why it looks like a heart with one big lobe there. You should probably have a heart specialist check that out. So the Heart Nebula seen here is located in the Perseus arm of the Milky Way galaxy. It has a diameter of 330 light years. The brightest part of the nebula, which is right around here, is separately classified as NGC 896 because since it was brighter, this was the first part to be discovered. There is a small open cluster known as Malal 15 that does illuminate this nebula. I believe it's clustered pretty much around the center there. And the cluster does contain very young, blue, hot, supergiant stars, about 1.5 million years old, which is no surprise, because we would still find the most massive stars, type O, in emission nebulae like this. Because gradually stars do leave the nebula, but perhaps not the really, really massive ones, because they burn their fuel so fast and then die off. So there we go. This is IC 1805, the Heart Nebula. Just enjoy one more peek there. Nearby is the Soul Nebula, because we have the heart and the soul. I think you can just make out a little portion of it. I thought you could, and on the chip here, it might be just over here, but we can't fit them both in at the same time. The field of view is pretty good. It's 4 degrees square again, but that's not wide enough to fit in both the heart and the soul with the Takahashi. So that would be a mosaic project. All right, so I'm going to go ahead and type in our next target now. Let me close some of these items, including that one. And for our next target, I'm gonna do it a bit differently here. I do not think the calendar catalog is in here. I don't think it is, but I can give it a shot. Yeah. Well, that looks pretty good actually. So yeah, the calendar catalog is in there, but I know how I want this to look, so I prepared a right ascension declination that I want to do. Although you can see we're still in the learning process, so I did not realize the calendar catalog was in there, but I shouldn't be too surprised. But I am. Okay, so I didn't have to tweak it too much. 5 minutes for this one will do. And we're going to go back to the luminance filter and double check my coordinates, but it shouldn't be too far off there. And looks good, and away we go. All right, so this is our next target tonight, Colander 39. known as the Alpha Persi cluster. So the calendar catalog contains 471 open clusters and was published by the Swedish astronomer Per Calendar in 1931. But not all objects in this catalog are open clusters. Probably the most famous example is Calendar 99, which is the coat hanger. You might have observed the coat hanger in wide field telescopes or binoculars. It's right inside the summer triangle. And that is not an open cluster at all. It's just a happenstance alignment of stars. I have done that with the Takahashi, but of course, it's the very wrong season for that now. And it is also classified as Malot 20. The Malot catalog contains 245 star clusters created by the British astronomer Philibert Jacques Malot and was published in 1915. And you can, of course, it's pretty easy to find. Basically, just look at the kind of wishbone shape of Perseus here. And the brightest members lie between Alpha and Delta Persei in what we call the segment of Perseus. The really bright stars here is known as the segment of Perseus. But I always thought it looks like a wishbone. There's kind of the short end here and the long end here. So, of course, everyone that picks the long end will get their wish granted. So, in fact, this star here is Merfac, and it is the brightest star in the constellation, even brighter than Algol, even when Algol is at its brightest, because this is a famous eclipsing binary star. And there's a bit more detailed chart. So, of course, you can find Merfac before you can find the double cluster, which is visible to the unaided eye. So it is very easy to see, and it's a very, very easy binocular target. Very nice binocular target as well. So this was discovered by the Italian astronomer Giovanni Battista Hordirna, who first logged this object sometime before 1654, but that's when he published his catalog. And obviously, since it's visible with the unaided eye, it's probably been known since ancient times. And it was Arthur Eddington who in 1910 first described this as a widespread moving cluster. Some assumed it was just an association, kind of a group of stars that did form together, but are not gravitationally bound. So, open clusters are bound by gravity, associations are not. But this is a true bona fide open cluster. Whoops. Should be oh, I didn't put a gap in there. Well, that'll be fine. So let's hop back to ACP, see how we're doing. Oh my goodness, what happened to the guiding? Hold on there. We lost the guide star. Uh-oh. Okay, we're gonna try that again because it's chasing the guide star. So let's give that another shot. And let me give you a little behind the scenes tour. So this screen here, this shows the computer in the observatory out in Arizona. So way over here on the right, this is ACP proper. So this is the actual program. Accessible through the web interface on the computer. The big thing here in the middle is Maxim. So this controls the camera and the auto guider. Up here, of course, you can see we have our weather station. And this program down here in the lower left is called M1 Oasis. And this is what controls the roof. So the winds are only 3.1 miles per hour. So I had wondered maybe if the wind pushed the star out, but no, the winds are very, very calm still. So no complaints there. And so you can see it just took a 20-second exposure. That's for the plate solving, so it can center the object to the desired coordinates. And once it centers the target, it'll look for a guide star. Plenty to choose from. Nice one there right in the middle, but I assume it'll pick that one. It's definitely not going to pick the bright one there at the top. That's probably Murphac. And there's our star. It looks good. And we'll just keep an eye on it there for a second. So that was interesting. No, it's kind of hopping around there. Oh, there it goes. I've done this before, never had any problems. And there she goes. Huh. And it's gone. All right, let me try one thing here. We're going to stop that. Okay, let me abort it from ACP here. Well, this is the first. So let me, of course, I'm going to turn off the auto guiding. Remind me to turn that back on, okay? And we're going to try that again. So I'll let you follow what I'm doing here. And so we're going to hit that again because we can do 5 minutes unguided fairly successfully with the Takahashi. Is it going? Try it again. There it goes. Just took a second. All right, so off it goes, and this time it'll start fairly quickly. It'll do the plate solving again, and but then it won't try to guide because for some reason we're not having success with a guide star there, which is very strange. But you know, stuff happens. All right, so it's going to start away there. So we'll have 5 minutes here. We should still have plenty of time to work with the plane wave. And again, I'm happy to answer some questions, or we can have some general chit chat. And perhaps while we're waiting here, if we're not going to hear from anybody, so you should be able to unmute. I don't know why some people can't. I can hear from some people, but not others.
Richard, I think each time that you unmute, you need to allow people or allow everybody to unmute again. So whenever you want comments, make sure you're saying unmute, because some people who have muted themselves in the interim can't unmute themselves until you do that again.
I see.
Yeah, that's
Well,
You
It seems
mute
to work out.
if you mute, like if we mute ourselves right now, then we will not be able to unmute.
Correct. You won't be able to unmute again until permission is given again.
Correct.
okay.
Richard, there's several.
Oh,
if you want to take a
I
second
don't.
to
I gotta check that. Hang on. There we go. I have unmute themselves checked now. I thought I checked that again, but now you should be fine now.
Richard, you might want to read the chat. There's, I think, half a dozen questions at least that you might want to answer.
Yeah, there are quite a few there. I don't know if I could find them all.
Yeah.
One question that popped up was, how do you know what filter to use? Another one is, we know we're seeing in black and white. What would the benefit be if we had color, or what would the difference be? Particularly, it was asked back when we were showing the Pleiades, say, what color would we see if it
Well, let me try to answer a few of those, Don. You're listing so many. What filter to use? It's just based on experience. Of course, with especially with emission nebulae, you know, to get a nice image, you want to use a hydrogen alpha filter. That that just kind of comes from experience and a bit of knowledge. You know, of course, the Pleiades doesn't really emit much hydrogen alpha light, so you don't want to use narrowband filters with the Pleiades, although you could, but no one ever does. But with the Pleiades, you just want to use a nice clear luminance filter for your main images, and the RGB filters, red, green, blue, for your color images. And so someone asked about the guider. Of course, the guider is to kind of compensate for minor imperfections in the mount. Even though it's a very, very good mount, no mount tracks perfectly. So over long time exposures, auto guiding is required. If it's really wide field, like with the Takahashi, we can do definitely 3-minute shots with no trailing, but 5 minutes should not be that bad with the Takahashi. So this image should still look fairly good, but because even with the plane wave, which is like roughly 5.5, 6 times the focal length, we can do like 2-3 minute shots with the plane wave and not have too bad a trailing. So there's that. And so somebody asked, why are we using the Takahashi instead of the plane wave? That's what a lot of people say. People expect us just to use the big scope because bigger is better, right? But good things come in small packages. There are certain objects we can't look at with the plane wave because it's a narrow field of view. So we can't see that beautiful image of the Pleiades. We couldn't see the Heart Nebula, and this cluster is definitely too big for the Pleiades. So there are definitely some advantages to a shorter focal length telescope, but I know many people want to see the big scope, and we'll definitely get there. So I try to do 3 of each.
Richard, you had a question. What is the focal ratio of the plane wave as compared to the
plane wave is roughly an f6.8, so pretty close to f7. The Takahashi is an f5, but of course the big difference is in aperture and focal length. The plane wave's a 20-inch. The Takahashi is just a little 4-inch. But it's a very, very sharp 4-inch. So scrolling back here to see if there are any questions, but I don't know if there's a huge demand to use nothing but the plane wave, that'd be great. But I personally love the Takahashi.
Person asked, would they be able to use their scope at home with an 8-inch aperture and be able to see color in some of the objects that they would view?
No, just double stars and planets.
I disagree with that. I have an 8-inch SCT and I have a color camera, and I can see all kinds of nebulas and things. Just your field of view is very narrow.
Oh, you mean with a camera?
Yeah.
But you can't see color with your unaided eye. I thought that's what the question meant.
That was a question. Sorry.
All right. There we go.
I've got a question. Can you run both scopes at the same time?
No, we cannot, because that was a huge issue. We had to have custom scripts written because we used the identical camera on 2 telescopes, so they cannot run at the same time. Basically the same driver, and so yeah, that was a whole fun story. But they're probably not precisely aligned with one another either. But that doesn't matter when we run them separately. So I'm assuming everyone here can see the cluster.
Yep.
So the cluster is basically mostly the bright stars, plus some extras, but all the other stars, those are background stars in the Milky Way. So this really gives you a sense of the 3-dimensional nature of space. So of course, the brightest member is second magnitude Merfac, or Alpha Persi. This is a spectral F5 IB star, 1b, which means it's kind of a white yellow supergiant. So it's warmer than the sun because the sun's a G-type star. So O, B, A, F, G. So O-type stars are the hottest. M-type stars are the coolest. So this is an F-type star. It's also quite a bit more massive than the sun, about 8.5 times the mass of the sun. That's not much compared to some other stars, but still 8.5 times the mass of the sun right there. It's about 68 times the size of the sun in terms of radius or diameter. It has a surface temperature of about 6,400 Kelvin compared to the sun's 5,800 Kelvin. It is over 5,000 times as luminous as the sun, which means it's brighter and gives off a great deal more energy. And it's about 510 light years away. The cluster is about 570. So I tried to do a little bit of research and see if there's some suspicion this is just a foreground star and not a true member of the cluster. But it definitely could be a closer member of the cluster. The cluster itself does have a diameter of about 140 light years, so that definitely encompasses the difference in distances. So 570 would be roughly from maybe the center of the cluster. So that could definitely make Murphak a member of the cluster there. And many of these stars you see are also type B stars. It is younger than the Pleiades, about 50 to 70 million years old, compared to the Pleiades, roughly 100 million years old. So there we have it. All right. So now we always like to do 3 objects. I'm going to clean this up a little bit. There we go. We always like to do 3 objects with the Takahashi. Well, I definitely do. And now we're going to switch to the big one. So we have a special program here to switch telescopes. So
did you remember to turn guiding back on, Richard?
Oh, I got to do that. Remind me to do that when I'm done switching here, so I can't make any changes now. And I gotta change the focal length of the focal length settings in ACP because that would be bad. Well, it would still work. It wouldn't like fly off the mount or anything, but you definitely want to do that. All right. So this is our next telescope. We're going to use the big boy. So we're going to put the Takahashi to sleep, and we're going to use the 20-inch plane wave.
Right, I know.
So this telescope here has a 20-inch mirror in the back. So that's why we refer to it as a 20-inch plane wave. Has a 20-inch mirror. Of course, you can see we have the secondary mirror safely covered up during the day when we took this picture. Very good idea there. And yes, this is our main telescope, a 20-inch plane wave, our pride and joy, our flagship telescope. A little fun fact here, Plane Wave is now headquartered in Adrian, Michigan. So they are now somewhat a local company. A group of us took a tour there toward the end of the summer of 2019, when you could still, travel and talk to people and stuff like that. Back in the good old days, I guess you can call it. So you can perhaps take a tour of their facilities sometime. So here's the imaging train of the CDK20. We already mentioned the camera a little bit. We use the identical camera on the plane wave as we do the Takahashi. I thought that might make things easier, but it actually made things maybe a little more complicated. And we focus with this little funny box on the back here. This is the Finger Lengths Instruments Atlas Digital Focuser. So this gently moves the whole contraption here backwards and forwards. It has like 105,000 steps, and it works very well. But when it is working, that thing is loud. And this little gadget here is an on-axis guider, which is a bit different than an off-axis guider. With an off-axis guider, you look for stars outside the field of view that you're imaging. So with an on-axis guider, we're actually looking for stars in the field of view. And that has many advantages, but I won't bore you with those facts. We can perhaps talk about that later. So what happens is the light comes in here, reflects off what we call a cold mirror here, and all the visible light goes up through a filter, and the filter will here into the camera, and pretty much all the infrared light goes into the guide camera, which has many advantages as well. Guiding is typically better in the infrared there. So this is the camera that we guide with, the camera that I have to turn on. And this is our mount. This is as we were installing it. So of course there's no telescope on there yet. And this is our software BISC Paramount ME2 German equatorial mount. Very, very hefty mount, very big, with a 240-pound instrument capacity. And I don't know how I did that. As you may notice in our PEC cam, we have a lot more counterweights on there to help balance the weight. But we're not quite, I think we might just be over 200 pounds, but probably not. So we're nowhere near reaching capacity on our Paramount there. Whoops, I forgot to put gaps between a lot of these. So where was I? Oh, I gotta remember. So let me make a quick switch here in ACP. I'll turn the auto guiding back on. And I'm gonna enter in the proper information because with ACP,
Did you change the focal length?
I'm doing that right now.
Okay,
With
excuse me.
ACP, we can only use one telescope at a time. So we have to change the focal length for the pinpoint to work properly. And while I'm here, I'm going to go to our very first target. So I'm just going to type that in NGC 7023. And again, I didn't like the way this centered it before, so I'm going to type in some coordinates here. Usually you don't have to do this. It does put it in the picture, but it doesn't put it the way that I want it. I'm very, very picky. I can't help it. Almost there. All right. I think we'll stick with 5 minutes. And we're good to go. So this is our target, NGC 7023, the Iris Nebula, an astrophoto classic, because it is a gorgeous target to take images of. So the Iris Nebula is widely known as NGC 7023, but like many objects, it has several different designations. In the Caldwell catalog, created by Sir Patrick Moore, the late Sir Patrick Moore, it is known as Caldwell 4. Caldwell is kind of like his middle name. It's also known as LBN or Lindbergh 487 or VDB Vandenberg 139, which basically the LBN VDB catalogs, they kind of refer to a dusty object. So this is a very dusty object. It was discovered again by William Herschel on October 18th, 1794. This is where you can find it in the sky. So we were previously looking over here, but now we're going to move toward the other side of Perseus or Cepheus. And so this is roughly the part of the sky that we're looking at. Not too terribly far away from Polaris, and kind of between Polaris and Deneb, really. So this object is getting low in the sky, but it should still look pretty good. It's fairly bright. So there's more specifically where it is in Perseus. It's about 3.5 degrees southwest of Beta Persei Alpherk, which is a very nice double star, by the way. And looks like we're trying to find a guide star. So sometimes this is sometimes listed as an open cluster, which is basically a mistake made by the Swedish astronomer Per Callender when he was probably putting together his open cluster catalog. He listed 2 open clusters in this region, but only one of those exists. So nobody's perfect. And it looks like we are well on our way to finding a guide star. So let's check in there, see how we're doing. Should be starting up here any second. Looks pretty good. Of course, I got to remove my windows around since we switched telescopes. Looks like it's fine-tuning the guider. We're getting there.
You got a couple of questions once you get things going there, Richard, in the
Sure.
chat.
Yep. Well, I'll just let it go there. We'll see what happens. All right. So, all right. What kind of maintenance do we have on these two telescopes? Basically, we have Mike Patton. If you look around various videos here, perhaps you can find one labeled Mike Patton. That is the member who owns the observatory, and he'll do some maintenance for us. He lives there during the winter months.
Maybe I guess people are interested if maybe we clean the mirror or we
did just have the mirror cleaned recently, and maybe this is getting a bit too low to image now because we're not getting a guide star anymore. When it does get low, we do get a little in the murky area. We would have got this last weekend because I did it the night before.
Yeah.
No, it's trying. There is a faint guide star in there, so it's a little lower since another week has gone by. Oh, nope, we're good to go. It's been working on it, so it sometimes it takes a little longer than we want.
You're sort of answering the other question above that, which is what kind, how does the system find the guide star? How does it work?
So what happens is with the guider, it'll basically take an image of the sky. And of course, it's programmed to look for stars of a specific brightness, which it can calculate based off the information of the telescope. And it looks for ones that aren't, it doesn't want a star that's too bright or too dim, but kind of maybe somewhere in the middle, maybe a little more on the dim side. And it'll automatically lock on it. It'll kind of do some auto calibration, which is what it was doing. And then it'll start guiding, which it's doing now. So we're about 30 seconds into our exposure now. Yep, you can get CMOS cameras are getting cheaper all the time. You can get a decent CMOS camera for now less than a enhanced DSLR camera. So now, really within the past couple of years, there's no reason to use your DSLR camera anymore for astrophotography. It's not horribly expensive to get a good CMOS camera. But of course, our camera is exceptionally good. We never have issues that you might have with the lower price cameras, like fogging, stuff like that. Number one, it's really dry out there. Number two, for the high price we paid for this camera, it has many ways to get rid of the fogging. So we never have any issues with that ever. Never. All right, let's peek in on ACP, see how we're doing. All right, so we are guiding away this time. Very interesting. We couldn't get a guide star in a very rich field of stars, or it did get a guide star, but it just seemed to drift out of the field. So that's very curious, especially for that part of the sky. It's not like it's very low.
Isn't it guiding right now, Richard?
It's guiding right now. I'm talking about the last target, our cluster here,
okay.
and do notice here's colander 39 again. And this is a 5-minute exposure, unguided. Mm-hmm. Now, when you do download these images, perhaps tonight, but tomorrow, maybe, you can look at the full resolution version of this, but peeking at it here, I don't see any major evidence of trailing. So that just goes to show you how good the Paramount is. That's a 5-minute unguided exposure.
We have a question.
Yep.
I have a friend who registered.
I see that. I just let 6 more people in, so people are coming and going. And hello to everyone there on YouTube. We do have some viewers on YouTube. Of course, they're on a 20-second delay. I call that hear back time. We have look back time in astronomy, where everything we see in the past, but by the time you people on YouTube hear me, that's 20 seconds in the past, so that's hear back time. That's copyright Richard Bell, by the way. You can't use that. So still pretty good guiding. The wind is very calm.
Looks like Mike has given an invite to anybody who wants to come out to Arizona while he's there, and he'll give them a tour.
All right.
Thanks,
The
Mike.
Nickel tour.
Question if they, I've got a couple of questions if they could stop by, but maybe not this year, okay?
Yes.
Mike, while you're on, Mike, I wonder, people that ask about maintenance, and of course you're there and it's your observatory. By the way, Mike's in his control room right now. And maybe you could say a little bit about maintenance of the observatory and the telescopes.
Well, maintenance is sporadic. There's no doubt about that. It used to be a lot more intense than it is now as we've learned to live with problems and repair them. There's very little maintenance that goes on nowadays. We cleaned the mirror for the first time in what, 2 years? Recently,
5.
you know?
The scope. We set up the scope at the end of 2015, kind of early 2016. So of course, for like the first year or so, it didn't get much use, especially 2017, because we were kind of preoccupied with the eclipse stuff. But yeah, it's been sitting in the observatory for about 5 years now.
We did have a moth infestation a year ago,
Yeah.
which really put some material on the mirror that we took off. But this trip out here, I got here in November. I haven't done anything. So it's
Mike, when you say clean the mirror, how do you do that?
Well, we used a very mild detergent and distilled water, alcohol to make it dry. There's a specific procedure to cleaning these mirrors. But one thing we've learned that we didn't really know is how dirty these mirrors can get and still get fantastic pictures, because dust is an issue out here. And the mirror can have what visually looks like a terrible coating of dust and produce a picture exactly like you're seeing right in front of you. So we've learned that.
All right. So hopefully you can see NGC 7023, not quite the quality I had hoped for. It is definitely a bit too low now compared to where it was a week ago. But you can still see some nice detail in the nebula here, but we got a little funny, kind of a funny glow around it. So it is getting a bit too low to target. It's amazing the difference a week can make. It looked a lot better a week ago. So this nebula here, which is another reflection nebula, very much like the Pleiades, this is 4 to 6 light years across, and it is illuminated by a pre-main sequence star called HD 200775. It's actually a triplet system consisting of a spectroscopic binary, which are 2 stars that you can only tell are 2 stars through its spectra. And it also has a 13th magnitude G-type star, a little bit warmer than the sun. Some sources say the protostar burst into life only 5,500 years ago, which is pretty amazing if true. And the star cluster Colander 427 shines through a small cavity in the nebula. Can you see it? See this cavity here? And this little group of stars inside, so we can see the cluster there.
Huh. About that.
So perhaps next season we'll try this in I don't know, maybe November or December. It'll be a lot higher, and because this is a great target. It just looks a little funky here because it is getting a little on the low side.
Mm-hmm.
But it would have been better last weekend, so I probably should have tried for something else. Oh well.
I don't know. That's a good lesson about the timing of taking a picture of your object.
It sure is. All right. Now, people in the past couple of months have asked me why I don't do more open clusters. Some amateurs kind of poo-poo on open clusters, but I love them. So let's go ahead and do a pretty famous open cluster, M38, Messier 38. So we'll click get coordinates there. We'll go ahead and stick with 5 minutes and acquire the image. It's off to the races there. All right, so here is our target, M38, the starfish cluster. And I gotta be honest, I've been an amateur for over 40 years. Not until recently did I learn that its popular name is the starfish cluster. I hadn't a clue. I just thought of it as M38.
First time I heard it.
Yeah. So Giovanni Battista Hodirna discovered M38 sometime before 1654. That's again when he published his catalog, and described it as a nebulous patch. So he must have not used a very good telescope. The famous Lejeune Teal, if you paid attention to the history of the Venus transit, the transit of Venus, he's kind of a famous figure involved with that. Lejeune Teal made an independent discovery in 1749, and he was the first to recognize M38 as a star cluster. And Charles Messier himself also noted it as a cluster of small stars on September 25th, 1764, and summarily added it to his famous catalog of objects that look like comets that are not, that you should avoid, at least if you're looking for comets. It is the faintest of the three clusters in Auriga. Of course, there's M66, or no, M36, M37, and then M38. I kind of always preferred this one, but some people like M37 a bit more, but we can do that next year. It is located basically right in the heart of Auriga the Charioteer, which again looks like a house, right between these two stars here, which is Theta Aurigae and Iota Aurigae. So draw a line between those two stars, and it's almost right in the middle. I think my little target there is probably a tad off a little bit, but it's also about 2 degrees northwest of M36. So this is definitely the lesser of the three. Most people tend to prefer M37, as I mentioned, but M38 is pretty good too. And you can see nearby is NGC 1907. That's only 32 arc minutes south-southwest of M38, basically like a moon diameter. And the two were once thought to be a binary cluster, but they have a difference in age of 150 million years. So a true binary cluster, two clusters near each other in space, would have the same age. Can anyone name the most famous binary cluster? You can either say it or put it in the chat, and I'll check on that later. It's a pretty famous pair of clusters. I hear. There you go, Don. That's it. The double cluster. All right, so we are off already. Looks like it didn't have too tough a time with the guide star this time. It shouldn't be. It's getting pretty high. And we are about a minute and a half or more now, really, into our exposure. So we are off to the races, as it were. So we can, oh, someone mentioned that it looks like a upside down pie. That was like the first thing I was going to mention when we see the picture. So that's good. People have been doing their reading.
I read it, but I was trying to look at the other night. I mean, I have a 6-inch dog. It's not huge. And I couldn't see the pie. I mean, I did see a cluster, and I thought it was that, but I want to see it now. Like, how does it look in the picture?
That makes two of us.
Yeah. So.
Well, I hope I got everyone's questions in the chat. Of course, if I missed you, you're always welcome to speak up. There's no reason to be shy. I know next year I'm going to, I've been doing this astronomy club stuff for over 25 years, and sometimes you get tired of tracking down volunteers. So next year I'll try to get more members involved. It is a bit tough to check the chat, let people in, control the telescope, introduce the targets all by yourself. So I definitely need to get more people involved. I gave subtle hints, but for those of you that have also been in the astronomy club for a while, you really know that you just can't ask for help. You have to ask specific people to help you. So I'm going to have to track down people to give a little extra helping hand here tonight. So
just a suggestion in the lowbrows this year, due to the pandemic, they created a position called an online coordinator, and responsibility is basically to take care of running the meeting and all of the electronics and stuff in the background.
Right.
And so it's definitely helpful, and it frees up the officers to do whatever they got to do.
Yep, that was my plan, is to have a host and an operator. But again, sometimes you get a little tired of tracking people down for help.
Ours is a board position, so I'm elected, and they said, you do it.
Still a volunteer position. It's not like they can cut your pay, right, if you don't do it.
Yeah, I've gotten 3 pay raises already, and I haven't seen a cent. So
you think being president for as long as I have, you'd make a small fortune, but nope.
Charlie Nielsen has the same problem.
Yeah. All right, I think we're almost done there. Let's hop back to ACP. Keeps moving around there. There it is. 25-ish seconds to go. Of course, this doesn't update every single second. Oh, the guiding looks a little more rough now. Oh, of course, the wind isn't that bad, but recall earlier when we looked at the clear sky chart, it said the scene would not be really good. So, yeah, it doesn't look very good. Based off the guiding.
So bad seeing gives similar results to guiding as windiness, huh?
Yeah. All right, I heard a bong. I was going to use the scope afterward to do some imaging, but with the crummy scene, maybe not so much. All right, there we go. I think I can see the pie already. All right, there's one bunk. All right, so now the actual image is loaded. There we go. All right, so cool. The cluster's brightest. So what we have to look for is the cluster's brightest stars form the Greek letter pi. I think I can see it.
Mm-hmm.
So yeah, there we go.
I think so.
That I would say that's a hit. So about a dozen of the cluster's brightest stars are arranged in a distinct cross at the center. That's another shape to look for. Maybe this way and this way. Look, it looks maybe the long end is this way. And then there's a cross there. So I think I can see the cross too. So I would say that's a hit as well. This is a Trumpler class Roman numeral 2R cluster. We won't bother to go in the whole Trumpler class. I don't think I could go through the whole thing anyway. But what the classification means is there is some concentration. It's rich with stars of medium brightness. So it's not a specific, really dense cluster, but it's kind of moderate. There is many members are type A, so warmer than the sun. There are some type Fs, Gs, and Ks as well. So pretty typical. There's probably some M-type stars, some red dwarfs as well, but those would be pretty faint. The brightest star is a G0 type yellow giant, so like a giant version of the sun, just a little bit warmer, with a visual magnitude of 7.9. Could be this little booger over here with the little spiky things, which is caused by the spider vane of the telescope. These are not real spikes coming from the star. It has an absolute magnitude of minus 1.5 and is 900 times more luminous than the sun. This could be a Milky Way star, but so it could be one of these stars as well. It's hard to tell in the exposure here, but of course, when you create the color image, that would pop out. It's about 36 light years across and contains 120 stars. So I will take 5 minutes to let you go ahead and count them. No, I'm just kidding. And it does have an intermediate age of about 290 million years. So over twice the age of the Pleiades. Very pretty. Excellent target. Of course, the other cluster, the possible binary cluster, which probably isn't, NGC 1907, is outside the field of view. It is a little denser, but it is smaller. So this is a good target for the plane wave. All right. So let's see. I always hit the wrong button. There we go. So back to our power. Yeah, Don.
Could you go back that? Oops. Could you go back to that image again?
Sure.
One of our people wanted you to show the pie.
Oh, okay.
You see in it.
All right. So this is the top of the pie. I think I'm right. Right.
Yeah. Looks like
this is the very top, and it kind of goes down here. Sort of looks like the Hindu, structure.
Oh.
And there's one part here. So pie top. One little part there, one little part there.
Well, when you visually observe, you have to use your averted vision. Now you have to use your averted imagination.
I figured you'd squeeze that in sometimes this season.
Thanks for the opportunity.
Now the cross, I guess I can see the cross, but boy, with a group of stars like this, you can make a cross out of basically any part of it.
I squint and it appears a little easier.
All right. Nope, not that one. All right. The main event. You know it. You love it. The Orion Nebula. This is one, we try to have new targets every season, but this is one of the targets like the Andromeda Galaxy we're going to do every season. So everyone knows, I think, the Orion Nebula, M42, also known as NGC 1976. It is visible to the unaided eye, but in this case, it might help to have use a little bit of averted vision. It's more than twice the angular diameter of the full moon, and it has a distance of 1,344 light years. Now, this time I outlined this because, as you might know, the Orion Nebula is what we call, technically a emission nebula, but it's also a stellar nursery, as most emission nebulae are. So this is a place where stars are formed. And what makes this special is it's not the nearest region of star formation. There's kind of some dark nebulae and Taurus that are closer, actually quite a bit closer, but they're very, very small. So this is the nearest region of large star formation to us. And it's over 1,300 light years away. So that's one of the things that makes the Orion Nebula so special. And I don't have to give you any instructions of how to find it, I don't think. Just look for the 3 belt stars of Orion, which we did look at last year with Takahashi. It's really cool with the Tak. And hanging off the belt is a sword. And again, if you use averted imagination or averted vision, Don, you made me do that, averted vision, you can see kind of a glow in the center of the sword. And that is the Orion Nebula. Obviously, because it's visible to the unaided eye, it's been known since, it's probably been known since pre-telescopic times, but we don't really have any direct evidence of that. There aren't any definite records of its existence before the telescope. It may have been mentioned in the Mayans' creation myth of the 3 heart stones or hearthstones. And in the myth, the nebula represents the embers of fiery creation. But it is not mentioned by Ptolemy, Al-Sufi, or Galileo. And of course, M33 is also part of the Orion Nebula. that sort of forms the head of the nebula. So here's a bit closer view of where we can find the Orion Nebula in the sky, but this is one of the targets that's very easy to track down with your unaided eye, but definitely binoculars and a telescope. And so let's go to ACP here. I did forget to put it in, but this time it doesn't matter. We're not going to take a really long exposure with this one, but we have plenty of time, so we can do several. So let's do 2 minutes with the luminance filter and let her fire off there. How are we doing in the chat? Well, I hope you saw the pie that time.
It's like people are seeing the cross, but not necessarily the pie.
Yeah, I did. I should have made Don the co-host, Jeff, but usually another member, Kevin, is the co-host, and he didn't show up. So, yep, I should have made you the co-host, Don. But I've been so preoccupied, I didn't think about it.
Yep.
I think that's all the current questions. Well, it was.
Let's see.
Nope, it is not.
Is it a cherry pie?
It is not a cherry pie.
I guess it is a cheery pie.
So you can see the whole plan here. You know, it basically begins the plan. It'll show you the exposure. It'll tell you it does the plate solving, but it keeps updating on me.
Is Mike still on?
I believe he is.
Mike, Patton.
Yeah, I'm here.
How many people? What sort of use are we having on the telescope being reserved?
Well, for the last couple of months, it's almost every moonless night. It's approaching 50% utilization. And when I say 50%, that's because of the late hours after midnight aren't as popular as the early hours.
Right.
But they're available.
I'm glad to hear it. So that's pretty good usage, I think.
Well, I'd like to see it used all night, but
right.
I don't stay up that late either.
Well, I was using it till about 3 a.m. our time last night, but not all night there.
Yeah.
I finished up a sequence of the Orion Nebula I'm doing with the Takahashi, which I need to process. And then I started a huge project of the Rosette Nebula, which we'll look at next month with the either the Takahashi or the plane wave. It looks good through both of them. Through the plane wave, you just really see like the center of it. You can't see the whole thing.
The only limit to the usage is I think people are afraid of it still.
Yeah.
And why don't you talk to that, Richard?
We do have, we have, last year we maxed out at about 191 memberships, which is probably about 300 people. And roughly 40 people paid to use the telescope. It's probably about 30 now. Some did not renew. But 30 people is still quite a bit. You know, that's basically one night a month if you're lucky. Once everyone starts using the telescope. But one thing I'm actively working on now is I'm just about finished with the new user guide, which is much more thorough than the previous version. And I'll be creating a training video that people can look back to over and over again. Because, yeah, the one thing I keep hearing from members is they're intimidated by it. But as you can see me working here, it's incredibly easy to use. It's just, click here, click there, enter data there. And
we have a question.
Let it go.
What does it cost to use the telescope?
Of course, you have to. I'll talk more about that later. You have to be a member of the Kalamazoo Astronomical Society and live in Southwest Michigan. So you have to pay your regular dues, and then you got to pay a $50 yearly fee. All right. Oh boy. So you can see the beautiful thumbnail there already.
Ooh, cool.
All right, now it's ready. There we go.
And could you speak about the filter choice here? We had
Yeah.
a question about
So I
filter.
used, yep, for regular shots, I just used a standard luminance filter, but for fun, we do have roughly 20 minutes of planned time left. We can do some other shots. We can do a quick shot through the H alpha filter. We can do some through some of the color filters, or maybe a couple other narrowband filters.
What about the horse head, Richard?
That's next month.
Oh, sorry.
So I'm gonna keep people hanging on that one. We'll do that next month. So let me tell you a little bit about the Orion Nebula. The mass of the nebula is estimated to contain enough material to create 10,000 sun-like stars, but it probably won't make every single one of those because it's not terribly efficient. It has an extremely young cluster at the heart of it, maybe 300,000 to 1 million years old. And there are currently about 300 stars emerging from it, but you can see those in infrared images from infrared space-based telescopes. The bright and sharply defined central cavity, which is overexposed here, is called the Huygens region, after the famed Dutch astronomer Christian Huygens. And the Theta Orionis star is a multiple star system called the trapezium, which is very easy to see through most telescopes. The trapezium consists of 8 separate components, A through H, possibly a 9th called X that has only been observed twice by the famous observer E. Barnard in 1888 and 1889. The brightest one, Theta 1c Orionis, is magnitude 5.1 and has 45 times the mass of the sun. So it is doomed. It probably won't even see its millionth birthday before it explodes. The projected distances between the trapezium stars is only about 1/3 of a light year, so they are pretty packed in there. So isn't it amazing though? This always amazes me no matter how many times I do this. This is a 2-minute shot with a 20-inch telescope.
Richard, maybe you could, I see in the chat, we're speaking again about filters, and one question was, though, can we save pictures with the telescope? Save that.
Yes.
Someone is using time.
If you are a Kalamazoo Astronomical Society member in the Southwest region, you can pay your dues, pay the user fee, and you can control the telescope all by yourself. You don't have to have me do it for you.
And then you get to save your pictures.
Yes, you do. And in fact, you have access to every picture ever taken with the telescope. Although I might clean out our current cloud account a little bit because there's some odds and ends in there. And we really just recently got the flat field system running. So we should probably purge some of the really old pictures and kind of start anew again.
Right. And now what I was going to suggest about taking, maybe you want to take another picture with a lesser exposure time so we can see the trapezium.
Let's try a red filter for just 45 seconds. Let's see what that looks like. And we'll just let it run there. So I was hoping we would have time to play, and we do. I worked it out to about 10 minutes of free time, but we have a little bit more than that, even with the little gating issue we had earlier. And another reason why I'm not used to asking for help, this is an old thing from my old job at the Kalamazoo Public Museum, which is now the Kalamazoo Valley Museum, is I used to work all by myself in the planetarium. You know, I set up the shows, I ran the shows, I pointed at stuff, I changed things out. So it's just an old habit for me to try to do everything by myself. But perhaps for a little more enjoyable experience, I'll try to get some members to help and find other members to host too. And we do have a professional astronomer in the club. We have a kind of famed high school teacher in the club, won many awards. And we have some people that can do great hosting as well.
Sure.
I'm sure other seasoned amateurs could do it. Doesn't necessarily have to be a teacher or professional or a former planetarian like me. Of course, I was a teacher too. So it'll take longer to do the plate solving, find the guide star, which it just did, than it will to take the picture. Of course, the great thing is when you're using the telescope, you can just set it to take images of a target for hours, and you can, watch a movie.
You can go unguided with these short exposures anyway.
Oh yeah, it will not guide if it's less than, I think, 30 seconds. So I don't know, maybe I should have tried 30. I forget what the minimum exposure is for it just not to bother guiding. But boy, 45 seconds is too long. We should probably even up that a bit.
Yeah.
Probably anything under a minute, you don't really need to guide at all.
Right.
Even with the plane wave.
Well, there we go.
Yeah.
Now, hopefully, in the images you'll download, you might be able to see the trapezium a little bit better. There we go. Still pretty bright.
That's the new thumbnail there?
Yep, it did change a little bit. I don't know if you noticed.
Yep. Oh, there we go.
I don't know why it failed the plate solve. I don't know why it says that. There we go. There they are. You see them? It's a little trapezoid, so you can see why they call it the trapezium.
Right. Well, it's amazing how much nebulosity you can see even with that short exposure.
Yep, and the red filter, that blocks out half the light.
Right.
So it's amazing how bright it is. So eventually you'll be able to download the full resolution version of this and really zoom in on the trapezium there. The absolute best view I ever had of the Orion Nebula was through a 20-inch obsession during the Winter Star Party in the Florida Keys. We were really zoomed in on the trapezium there, and it was like looking at the close-up Hubble image of the trapezium, just in kind of a pearl gray light, because of course you can't really see color. Although I have heard through very big telescopes, maybe like an 84-inch at McDonald Observatory, you'll see pinks and other colors as well. I would love to see that sometime. Shall we try hydrogen alpha?
Sure, try that. Maybe knock it down another 10 or 15 seconds.
Well, with hydrogen alpha, I want to go a little bit longer, just because that's to really pick up the nebulosity. So let's go ahead and do 2 minutes again. For most targets, 2 minutes is pretty short for H alpha, but the Orion Nebula is plenty bright, so that is not a problem. So while we're doing that, let me do my closer here. So as we talked about already, you can join the Kalamazoo Astronomical Society, or if you are already a member, you have the potential to use the remote telescope. It's just the one caveat is you do have to live in one of these counties in red and Southwest Michigan. We have had plenty of requests from people all over the country to use the telescope. So it would get to the point to where, local members would never be able to use it. So that's why we kind of put that limitation on there. But we have talked about maybe having different rates of pay. For out of area residents, we can charge more, kind of like colleges do, of course, with, U of M, it's cheaper if you live in Michigan as opposed to outside of the state. So that's something for the committee to talk about in the future. And a little preview for next month. Please mark your calendar for February 6th with a little note of a cloud date, or as it usually is this season, a wind date, February 13th. That'll be our last session of the year, because once we get into March, daylight time ends pretty quick, and we'd have to start an hour later than we do already. And remember, it gets dark right at start time. By this time next month, it won't even be fully dark yet. but dark enough to look at the all sky camera.
Oh,
we only have one left. Hang on there, Don.
Okay.
And so if you are not a member, you can join the online viewing session email list. So if you join the email list, which we send out to non-members, you can receive reminders about sessions. You can get the registration and YouTube links. You can have the link already to download the images instead of having to type the URL that I'll show you later or copy and paste it from the chat. And of course, you'll receive notifications of postponement like we did last Saturday or of a cancellation. The good news is we have a perfect record. This is our 7th session like this, and we have not had to cancel one yet. We do have a contact form that you can select an option to be put on the online viewing session email list, but just email us at kas@kasonline.org. And of course, one of the things I might send out later this year, come October, is the 2021-2022 schedule of online viewing sessions, because we are going to continue doing these online. This was the plan long before the pandemic, so the pandemic has nothing to do with doing these online. It's just it's cloudy this time of year, it's cold, so why not stay inside and have some fun with the remote telescope out west there. I want to give a plug for my Introduction to Amateur Astronomy lecture series. This is a 5-part series, all-encompassing, that begins on January 23rd. You can go to our website, go to the activities menu, and find the link to the Introduction to Amateur Astronomy webpage. Here's the amazing thing is I have contacted clubs all over the country and Canada, and we currently have about 560 people signed up. We'll see how many of those people, actually show up. I hope quite a few. Be sure you join us at our next general meeting. It is on Friday, February 5th at 7 o'clock. Of course, that's Eastern Standard Time. We have a fantastic guest speaker, Dr. Jessie Christensen from the Exoplanet Science Institute at Caltech. And so she is a noteworthy person in that field, which is very hot in astronomy. So you can go to our website and register for that right now, so you don't forget. And here is the link to download tonight images. Obviously, don't go there right now. I'll have to download them, do a little bit of processing, and then I'll upload them to the file or to the website at this link. So if anyone wants to really help, you can maybe put this into the chat. Someone usually does that for me. Or, of course, if you're on the online viewing session email list, you already have this link. But you can always contact us if you lose this or lose the chat, lose your copy of it, and download the pictures. So I'll keep that up there for another hot second. We can always come back to it.
So, Richard, David Burnett asks, why not Berrien County? And I guess that would have to be, I can sort of answer that as part of the committee. We at this point have designated the counties that were in red there. And when the committee meets again, and we can always vary that, but right now the counties that were shown in red are the counties that we're allowing to reserve time on the telescope.
Yep, and we mainly pick the counties that border Kalamazoo County.
Right.
Of course, we made one exception for Kent County for obvious reasons. There's a major population area there, but we may add more counties. Yeah, I do know that Berrien might be a bit of an oversight, but we do not have too many members from there. But if we can pick up more, we would probably almost certainly add it. So here's the Orion Nebula in H alpha. So this is a 2-minute shot with a hydrogen alpha filter, and you can tell the nebulosity is quite a bit more sharp as compared to the luminous filter.
Another question, Richard, is, I see Mike Patton answered. Never mind, forget it.
Okay. Yep. Based on my, based on the early days, like 1995 of America Online, when that first came online, I got my full of chat rooms back then. So ever since then, I could care less about them. So I'm terrible at looking at the chat. All right, so we only have 4 minutes, but last month we did do a little extra viewing, but I've been on the computer quite a bit today, but I'm happy to stay on a little bit longer. I've been working on the user guide all day. That's turned out to be a bit of a challenge to lay out, but I'm getting there. I'm almost done. And someone asked, could we see Barnard's loop? Not with either the Takahashi or the plane wave. That's way too big for either telescopes. That's more of a kind of a wide field lens target. Someone asked about the O3 filter. We do have a couple more minutes. Anyone want to see the Orion Nebula with the O3 filter?
Yeah.
Give me a show of hands there. All right, let's do it. Let's do it. Just one more ooh and ah. Ooh. Okay.
That is cute.
All right, let's do O3. We'll stick with 2 minutes because I go more for nebulosity here than I do the trapezium. And
of course, if you were doing this to make pictures of your own, you would take them in both situations and then overlay using processing software.
Yeah. If I can get more members to help, one thing somebody else could do is download the images as they get uploaded to our cloud account, open them up, and we could take a peek at them. But it takes, we're using DSL out there. We got like, I think 20 megabits a second if we're lucky. And so it takes like 3-4 minutes for each image to upload.
Sure. So your idea being, of course, we wait for some images that were taken, 20 minutes ago, put them on a co-host computer and use full screen and share the screen, I guess. Is that what you're saying?
Yeah. Especially when we're doing those 10-minute H-alpha shots and we have some time to kill.
Right. Yep. Let's see. Asking about season, whatever it says here. Oh, by the way, once you join our club, if you're in one of those counties shown in red, that Richard showed, the extra fee to use the remote telescope is $50 per year.
Yeah. And I do want to mention part of the Introduction to Amateur Astronomy lecture series, the final part 5, is on astrophotography. And I mainly cover the more basic stuff, starting with tripod photography. Everyone should start with tripod photography. I know people want to jump right to the mounts and telescopes and stuff like that, but no. Start with wide field images. It's almost in many ways as satisfying as taking pictures through telescopes. But I will give you lots and lots of advice about what equatorial mounts to get, starting out with short focal length refractors as opposed to a Schmidt-Cassegrain. And I will touch upon image processing, lots of different programs to use. So it's a very all-encompassing getting started lecture on astrophotography. And boy,
answer a lot of these questions that people have asked through the night.
And I do want to mention that the original version of the lecture series, especially the astrophoto section, had an extensive section on film, and I had to retire that, obviously. So we have more questions, Don?
It was just that they were asking questions like. Sounded like, does the telescope run an autofocus routine when changing filters?
I see it. Yes, there is a way. Let me show you that. So if you go to color series, you can see there's autofocus at start. I can check that. And like if I have, say, like 2 images with a red filter at 2 minutes, it'll focus for the O3 filter, which usually doesn't go very well with narrowband filters. But when it's done with this filter and goes on to the next one, it'll refocus. But the great thing is with our very pricey filters, they're all parafocal with one another. So we don't have any problems with the luminance or red, green, blue filters, but so far we don't have much success in focusing with the narrowband filters, and we're gonna look into that. But you can focus for the luminance filter separately. In fact, you can go down to utilities here and focus using Focus Max. We use a program called Focus Max to focus. Of course, ACP controls Focus Max entirely, and it'll focus between each filter. And of course, you can see, you can check this, and it'll focus every 60 minutes, 90 minutes. Last night, I had the telescope refocus every 90 minutes. The Takahashi doesn't suffer too bad from differences in temperature. The differences aren't too extreme. Well, there we go there. Whoa.
All right.
Look at that. Look how M43 disappeared and O3. It's gone. That's interesting. You can just make out the trapezium, so that is O3. Of course, the nebula gives off a lot more H alpha than it does O3, so very different appearance there in O3.
What brand name filters are you using?
The best, baby, Astrodon. People always ask, how much does this cost? I'll tell you. One of the narrowband filters, like the H alpha filter, which is 50 millimeters square. Are you guys sitting down? $1,200.
Too much.
So we had some very, very generous members help us raise a great deal of money to help pay for this entire project.
Ask me how many Astrodon filters I own.
How many do you own, Don?
0.
But your name is Don. Every filter you own is kind of a Astrodon filter.
I wish they felt the same way.
So looks like our screen froze here. So here is the current configuration of the remote telescope. I just figured we would say adieu to it here. So of course you can always go to the PEC page. Based on the scene tonight, I'm not sure I'm going to image anymore. But I do want to thank everyone for joining us tonight. I hope you join us for the lecture series, for the meeting, for the last online viewing session. We definitely have plenty of activities, and they're all pretty good. So I hope you all had a great time tonight.
Thanks, Richard. Appreciate your time.
If anybody wants to ask any questions or just chat about astronomy for a bit, I'm more than happy to.
Hey, Rich, you're going to want to check the seeing out here. It's not that bad.
Oh, okay.
It's a little over 2.
Well, based on those guiding issues that we had earlier, it looked like they were pretty awful.
To the north, it's about 2.
Well, you might have been low in the sky, Richard.
Yeah.
So, you're reserving the time right now, or?
Well, no one reserves the time, or no one really asks if they can reserve time after the session ends. So usually I just kind of let it go for a while.
Right.
Last month we spent like at least a half hour looking at other stuff, but then eventually the wind hit us.
Right.
Well, I'm going to leave you. I got to go feed the owl.
Thank you very much, Richard.
Yes, I love our new owl.
Oh yeah, yep.
So do I.
Yeah.
I got to go feed him.
Night.
There's a western screech owl living in a bird house at Mike's place, and he's been coming in very handy eating mice. There's also kind of a neighborhood roadrunner that's been hanging out around the observatory eating mice as well. And Mike's noticed the mouse population has gone down dramatically in the observatory. So that's good news for us, because we've already had to replace like at least 2 cables from mice, from mice damage.
I have to go from Illinois. Thank you so much for sharing the sky, and we'll see you next time.
Thank you, Dee Dee.
Okay, have a good night.
Yep. Any other questions? All right. Mohammed, is that view of the aurora live?
No, it's just a background.
I
Virtual
know.
background.
Yeah, I wish
Yeah,
we could.
yeah.
If you go to explore.org, you can see the aurora in
Yeah, I've been seeing
Churchill.
it periodically. It's beautiful. I love auroras.
Let's see if it's clear in Churchill tonight, real quick. Let me go to the website. I have it bookmarked here.
I had the privilege of seeing it once in Iceland.
Oh, cool. Oh, it is clear out there tonight too. So for those of you that are left, let me go back to my browser. So you can go to explore.org, look for the link for the Aurora Borealis from Churchill, Manitoba Canada, not calendar. This is probably exhaust from a building nearby, I think. It doesn't look like a cloud. We do have some aurora there. I can't tell what part of the sky we're looking at. We're obviously looking kind of low, but I can't quite tell what constellation this might be here. Usually you can make out the constellations. Oh, no, this is Perseus. This looks like Perseus. You can see the Perseus segment here in the wishbone. This is probably Murphak. No, that can't be Perseus. It's too low. Huh. Well, with this big funky cloud here, I can't tell what it is. But always go to explore.org. We're also getting into aurora season too. Once the Hudson Bay freezes over a bit, the skies are a little more clear. For December, January, it's usually pretty cloudy.
You get a lot of them up in Labrador too.
Yeah. Boy, we haven't had a good aurora display here in Michigan. Probably, I mean, a really good one since 2003. The sun's been kind of dead.
You're talking about the UP?
No, from here.
Oh, really?
Even from my back, it was great from my backyard.
Wow.
I saw one once as a kid. We were actually sleeping on the boat in Higgins Lake, and it was probably June, July or something, and it was gorgeous.
Oh, somebody wants to,
but still beautiful.
Somebody wants to see the all sky camera again, so let me go back. There we go. So you can see Canis Major's getting quite a bit higher there. My target that I was working on last night, of course, after the Orion Nebula, the Rosette Nebula, that's like this little smudge, I think, right there, or here. It's around here somewhere. The telescope knows where it is. So don't forget, you can always go to our website. You know, this menu looks the same from every page. So go to Remote Telescope and go to the Peishi all sky camera. Oh, I didn't mention Peishi is Apache for Nighthawk. So I don't mention that every time. I'm surprised no one ever asks, what does Peishi mean? And we're pretty sure it's pronounced Peishi, but we have yet to have that confirmed from a Apache. All right, well, I'm going to go ahead and sign off here. Oh, I should have ended the YouTube stream already. Oh, so for those of you that are still on YouTube,